Hello students, this time we are going to start with the next topic, that is thermodynamics. Now, thermodynamics is a branch of physics which deals with the study of transformation of heat into various forms of energy and vice versa. Alright, transformation of heat into various forms of energy and vice versa. This is thermodynamics. See, thermodynamics is a macroscopic science. Macroscopic science means it is a science which studies macroscopic variables of a system. Now, I just said macroscopic variables of a system. So, to understand thermodynamics very well, you will have to first understand few terms which will be very frequently occurring in this chapter, such as system, surrounding, then we have variables and what else? Variables and walls. Okay, I'll write it first. Let me explain you what is system and surrounding, then we'll go to variables and walls. See, system is a collection of large number of particles. Particles could be atoms or molecules, anything. System is the combination or collection of large number of particles which are enclosed by walls, right? So suppose there is a gas contained in a container. These are gas particles, molecules, right? So this is a system. Surrounding means anything outside the system is called surrounding. Now, how do we define the state of a system, whether this system has reached a saturation state or it is in an equilibrium state or it is in very unstable state? To explain the state of a system, we use terms like variables first. So what are variables? These are the macroscopic quantities which define the state of a system. The major variables are pressure, volume, temperature, then mass as well as the composition of the system. See, system is a collection of large number of particles, so system may consist of solid, liquid or gas or the combination of any two or more states, right? So system could be anything. Variable is pressure, volume, temperature, which defines what exactly is the situation right now with the system. Alright, surrounding is easy. Surrounding is anything outside the system is surrounding. Now, as I told you that system, this whole set of particles are contained by walls. So you should know about wall as well. Wall is an insulation, either conducting or non-conducting in terms of heat. So walls are insulation which contains all these particles. So walls could be either adiabatic walls or wall could be either diathermal walls. What are the diathermal or diathermic walls? So adiabatic walls are those walls which do not allow heat to pass through them at all, whereas diathermal walls are those walls which easily allow heat to pass through them. Simple. So suppose this is adiabatic wall, and if there is heat present outside, this heat will not enter the system. But if it is a diathermic wall, the heat will easily enter the system. This is what I mean by wall. So basically it's a just classification which we use to put heat into system or to remove heat from the system, because thermodynamics, as I told you, is the study of everything with heat, right? And we have to deal with those macroscopic variables which are pressure, volume and temperature, right? See, we have already studied mechanics, right? What was mechanics? In mechanics, we studied about the motion of particles with the consideration of the cause of motion, right? Thermodynamics is completely different from motion because we are not looking into microscopic quantities as such. If temperature is increasing, how much will the kinetic energy of each molecule will increase, or what would be the new motion of the particles? We are not concerned about that. We are majorly, or we are quantitatively checking the values or the change in these variables. So let's start with this chapter. The first thing you should know is what is thermodynamic or thermal equilibrium. See, I said thermal equilibrium. Thermal equilibrium is very simple. It means, suppose this is a system of n number of particles, alright. This system is supposed to be in thermal equilibrium if its macroscopic variables like pressure, volume, temperature, they do not change with time. the system remains as such or as in initial condition as it will be in final condition. So there is no change in pressure, volume, temperature with time. Then the system is basically called thermal equilibrium. So thermal equilibrium actually is related with temperature. If the temperature of the system is constant, there will be no increase in temperature, then there won't be any increase in pressure or in volume. Or if there is no decrease in temperature, there won't be any change in pressure and volume. So see, temperature is major factor in changing pressure and volume of an enclosed system. So thermal equilibrium can be stated in two ways. Either one thing is, as I already stated, that when variables are not changing with respect to time, or when the temperature is constant, that is called thermal equilibrium. So thermodynamics is classified into four major parts, and we'll study with the first, which is the laws of thermodynamics, that is Zeroth Law. We are studying with the first law of thermodynamics. This is called Zeroth Law of thermodynamics. Now, why it is named so? Why Zeroth Law was coined as such? See, Zeroth Law of thermodynamics. Actually, the first and second law of thermodynamics were already stated, and the Zeroth Law, which is more fundamental law, which deals with the basic change in temperature or basic equilibrium of temperature, that law, which is Zeroth Law, is applicable on both first and second law. It's a very basic and fundamental law. So it was to be, or it was supposed to be stated before that. That is why it was named as Zeroth Law. What this law states is, suppose we have three systems, system A, system B, and system C. System A, system B, and system C. Here we have adiabatic walls. That means there is no transfer of heat from system A to system B, whereas here I have diathermic wall. Okay, that means heat can easily flow from system A to C and B to C, or vice versa, but heat cannot internally flow between A to B. Now Zeroth Law states that if two systems are in thermal equilibrium with a third system, suppose A and B are in thermal equilibrium with each other, and B and C are also in thermal equilibrium with each other. So if two systems are in thermal equilibrium with a third system, then the two systems are also in thermal equilibrium with each other. That makes sense, because if A and C are in thermal equilibrium with each other, that means the temperature of A and C is equal. Similarly, if C and B are also in thermal equilibrium, that means the temperature of B and C is also equal. That means the temperature of A and B is also the same. That is what the law states. If two systems are in thermal equilibrium with each other, if two systems are in thermal equilibrium with the third system, then these two systems are also in thermal equilibrium with each other.